Good morning, sir. This is our project Intelligent Model for Heart Disease Prediction using Machine Learning. We are doing our project under the guidance of Sivakumar, sir. This is our teammates Tejaswati and Madhavi. This is our industry details. This is our agenda. Abstract. The project focuses on heart disease prediction, a major difficulty in clinical data analysis. Machine learning techniques are well suited for extracting valuable patterns from massive amounts of data. We are using classification algorithms such as logistic regression, support vector mission, decision tree, and k-nearest algorithm with degrees of accuracy. This is our abstract. We suggested a model for predicting heart illness based on the patient's numerous heart features and detecting heart disease using machine learning methods such as logistic regression SVM-KNN. They are less accurate and take somewhat longer to process than the suggested model. This is our aim and scope. The project's goal is to predict heart disease, which is crucial problem in the field of clinical data analysis. And the scope is clinicians have an limited amount of time to examine all of the available data and identify incomparable medical records. Various supervised machine learning classifiers such as random forest, decision tree, SVM. We are employed in the mentioned model to deploy a model for heart attack prediction. This is our introduction part. Heart disease is the leading cause of mortality mortality in humans. Machine learning is a newer artificial intelligence technology that adds numerous HD algorithms. These are the literature review, and this is our papers with heart disease prediction using machine learning algorithms, developing a hyperparameter turning based machine learning approach of heart disease prediction. And next is comparative review of feature selection and classification model. These are the papers. And next is the design and methodologies. EDA future selection smart algorithm model building. And first is EDA. The procedure begins by importing the required models from the source libraries. The exploratory data analysis, which is critical stage in investing and evaluating various data sets, as well as summarizing their main accepts. In EDA, essential for uncovering hidden patterns, recognizing outliers, key variables, and identifying data anomalies. This is the feature selection. In this feature selection, the data is divided into X and Y, and the X is training data and Y is testing data. Several characteristics such as age, gender, that indicates personal information and data properties associated to each patient. Heart stroke problem is the one of the most crucial segment in heart disease prediction. And next is smart algorithm, synthetic minority over sampling technique. This is model building and standards and policies used. We are using Python standard, ISO and IEC, and we are using Anaconda software. This is the implementation part. This is the architecture diagram, importing libraries, data cleaning, data visualization, splitting of data into X and Y, smart algorithm, but best is the SVM and heart disease predicted or not. Data flow diagram level 0, patient prediction of cardiovascular disease, multimodal machine learning algorithms. Next is level 1. This is the ER diagram. And sequence diagram. This is the collaboration diagram. These are the testings: unit testing, integration testing, functional testing, white box testing, black box testing. First is unit testing. Unit testing is used to ensure that each model component of the project is working. Integration testing. Integration testing is methodology for building the software architecture while running tests. Functional testing. White box testing. White box testing is also used for basis path testing, and this is also known as glass box testing. And next is black box testing. These are the inputs while we are giving the inputs to the heart disease prediction, and this is the final output of our implementation. Possibility of 60% heart disease. This is the conclusion. This works deeply into machine learning approaches of heart disease categorization. Future enhancements. New AI algorithm will be required to verify the accuracy estimation. These are the video links and web references. References as per IEEE format. This is the plagiarism report of our PPT. 2% plagiarism. This is the poster presentation. Thank you. And coming to our implementation, this is our implementation. First, import warnings. We want to ignore the warning, so we are using the ignore function. And then libraries, NumPy, Pandas, Matplotlib, operator Seaborn. NumPy is used for processing with arrays, Pandas reading the CSV files, and this is the dataset. We are using framing.csv dataset, and in this head functions fills with the columns like male, age, current smoker, BP, systole BP, diastole BP, diabetes, cholesterol, BMI, heart rate, glucose, like that. EDA, missing variables. Here we plotting the missing variables and calculating the missing values in the data frame. Here glucose has the highest number of missing values. This is the chart. Data distribution into X and Y categories like BP, cholesterol, BMI, glucose, heart rate. Number of people who have diseases versus age. Here, this is the data analysis. This is male, female, not smoker, smoker, diabetic, non-diabetic. This is our future selection. In this evaluate, we need to evaluate the data set and select important and unimportant features. And the data split into X and Y categories 0 and 1. 10 to 14 means rejected 0. If 3 by 3 means confirmed. Models smart. I already run the code. All are, yeah, this is the F1 score for the logistic regression is 62.37 accuracy. And then k-nearest algorithm